Thank you, Helen. So again, welcome from my side. I'm Karine Chuto-Jomo, and I'm together, as already mentioned, with my colleagues Volker Drees, Stefan Mettes, and Simon Collett. We are all from the ABAP platform. And yes, we are delighted to offer this session for the community. The usual disclaimer applies. And here is the agenda of today's webinar. First, we'll give you the big picture of the ABAP RESTful application programming model, short wrap. And after that, just a quick introduction about today's scenarios overview, and then we'll have the demo. So this session was offered during the TechEd as a workshop, hands-on workshop, but here we are going over to a demo-rich lecture. And at the end, we will summarize. So without further ado, the big picture. The ABAP RESTful application programming model. RAP is a strategic investment on the ABAP platform to best support the rapid development of modern applications. So it's very central because it provides on the ABAP platform a universal programming model for different types of development. So for building SAP Fiori applications, but also web APIs. And with different scenarios we are used to on the ABAP platform, meaning starting from scratch or by integrating legacy code. It's very important because we offer the same programming model in the cloud, but as well as on-premise. So in the cloud, on the ABAP environment, and on-premise on SAP S/4HANA. It offers a standardized development flows for transactional read-only, but also analytical apps. So with this programming model, we can really build different types of application in contrary to the past where we had to use different UI technologies to do the work. We also offers best practices and very elaborated development guides to guide you through this programming model, how to really help you to have a quick ramp up in this area. A very important aspect of this programming models is that it allows developers to focus on the business logic rather than technical aspect. That means developing an application maybe on the gateway levels. That means all those, depending on the scenario you are running, all those technical aspects are taken over by the underlying application infrastructures. Aspects such as testability, documentability, and supportability are all natively integrated in this programming model. It's important to mention here that when we talk about the ABAP RESTful application programming model, here a lot of investments have been done in the kernel and the ABAP development tools in Eclipse, but also in the underlying application frameworks. It also provides best support to SAP HANA and SAP Fiori development too. And that means you can really leverage the power of the underlying SAP HANA database in your applications using the advanced capabilities of core data services and also the ABAP managed database procedures. Also, an important aspect is that we can build both stateless and stateful applications with this programming model. Yes. And also aspects such as extensibility are also really built-in capabilities, and also offers flexibility for breakout scenario when it comes to non-standardized implementation, so very specific implementation. On the screen, we can see the end-to-end development stack, so high-level architecture of the end-to-end development stack of the ABAP programming model. And we can divide it into 3 layers. So at the top, we have the data modeling and behavior layer. This is the world of the data model, now where the data model and its associated business logic lives. Typical example in SAP S/4HANA, then we are talking about the virtual data model or all the artifacts that are in the ABAP dictionary, data element and so on. And also for the logic, it can be stored in classes or wherever. So that will be the pendant. So we have two sides here. We have the non-transactional world of queries, where we can then describe our queries using core data services and yes, to build analytical reports, for example. Then on the other side, we have the transactional world of business objects. And here, the aspect of business object, like in real business, for example, we have a typical sales order invoice, but also a flight, travel, booking, and so on. So these are kind of business object, and they have on the conceptual level, they can be divided into three parts. First, the business object structure, so the data model, which is materialized in the ABAP on the ABAP platform with core data services. So you can build, define your data model with CDS. Then we have the second aspect is the behavior of each business object, so the transactional behavior. And this is done with a new artifact in the CDS world called behavior definition. And the third aspect, also materialized in the system, is the implementation, the runtime implementation of this behavior, which is done with ABAP. Once we are through with the data modeling and behavior, we can go on the business service and provisioning layers. And here we have, for the business object, a so-called business object projection. So this is the use case specific exposure of a business object. That means all the relevant object attributes and behavior of a given business object can be defined here. No? This is typically the place where you can also denormalize your data model. That means where you can enhance your data model with additional information on the data model, but also on the metadata layer. This is done here. And also out of all the behavior that are allowed on a business object, you can then expose only those that are relevant for that given scenario. And also we provide the possibility, then the idea is to enhance it. For example, if we have an LOB, a line of business specific functionality, then it can be implemented here using also behavior implementations. Once this is done, then the service scope has to be defined. That means we have to define which entities should be part of the OData service we want to expose later on. So up to the service definition, a developer works in a protocol agnostic manner. That means it is really independent of the protocol that is used later on. And here is just also done in a declarative way where you can specify which entities should be exposed. And once this is done, you can now go ahead and bind the service definition to a given protocol. Service definition and service binding are new artifacts that have been introduced in the ABAP world, and this is the successor of the SAP Gateway Builder. So this is the new way how we build our data services on the ABAP platform. And also at this layer, you can also define whether the service you are building is for UI purpose or should just be exposed as a web API and consumed by the third parties APIs too. So. Again, let us have a look again at the business object, because it is very important here. The business object is really a central, a major concept of the ABAP RESTful, ABAP RESTful application programming model. As already mentioned, we have the data model. The data model or composition model is a composition tree where the different nodes are related, have a kind of parent-child relation defined between them, and we have a root. Every BO structures composition tree has a single root, and the other entities are then defined and the relation defined. All this is done with CDS, using CDS modeling entities, CDS view entities, CDS projections, and so on. Then we have the so-called the behavior, where you can first define the CRUD, the create, read, update, delete operation, but also application or business object specific actions function. You can also define the log handling and also aspect like draft and authorizations. Draft is very important. It's a very important capability because it helps us to build stateful applications using stateless protocol technologies such as OData and HTML5 UI controls. And here we use the CDS behavior definitions. And the third aspect, already mentioned before, is the business object runtime implementation. So this is where the proper implementation of all the business object specific logic defined in the behavior should be then really implemented. And here we have two main phases. We have the interaction phase and the save sequence. The interaction phase is used to perform all the modifying, reading and locking interaction, and this is a recurring task. You can imagine, for example, in case of a UI application, when the end user click on edit, then you had started an interaction phase, and all the modification performed in this phase are temporarily saved in the transactional buffer. Once this is done and the end user click on save, so when the save event is triggered, then the save sequence is then processed in a given order to persist the data on the database. And the question here the whole time now is, where do the ABAP developers come into action? And what do they have to do? What are they responsible for? And here it depends on the scenario that is being implemented. The first scenario is the so-called unmanaged scenario. So it's the unmanaged runtime implementation types. This is typically for brownfields developments. That means the developers have already legacy code available for the whole interaction phase, but also the save sequence and the transactional buffer. And they want to reuse it. For example, they have some function models or the ABAPs they want to reuse. And that means here the developers is fully responsible. He's in charge of integrating this existing logic inside the RAP BO runtime. And to do that, he has to build, to develop kind of adapters to integrate that. So an adapter here is only a piece of software to do the mapping between the interface of the RAP framework and the interface of the existing logic. The second scenario, so this scenario is typically also available on the SAP S/4HANA platform, where you want to reuse your existing code, but also in the cloud if you have moved existing code to the cloud. The second scenario is the managed scenario. This is typically for greenfield developments with standard implementations. Here it's important, that means you want to start afresh. And when you do the managed scenario, the standard create, read, update, and delete operations are available out of the box. So generically provided by the RAP framework without the need of a single code of line. So as soon as you've declared that your business object is a transactional one, then you can already create, update, and delete the object, the entities, the instances. And then some dedicated code exits are provided to allow developer to add the business object specific business logic. A typical example, I'm creating a new travel instance, then of course the RAP infrastructure will be able to save it, but will not be able to provide an ID or to do any validation or whatever. So, and this is the place now where you can provide the frameworks with the value, the validation, and the so-called determinations that needs to be performed during those actions. And this is our today's scenario and the focus of this. A typical development flow, and you will see it later, I'll just go quickly, is to develop the database table, then to the CDS data model, using CDS, define the behavior definition, and then provide the appropriate ABAP code. You can reuse ABAP log objects or make use of authority checks, so authority objects, and also CDS rules here. That is all about authorization aspect here. Also, ABAP unit test is provided here. It's supported for the different entities. Once this is done, then you can project the elements and enrich it as needed. Also project the required behavior projection. That means all the data model and the behavior that is needed for the given scenario, expose it, bind it to a protocol and a use case, and then preview. Also at this level, you can also define rules and do ABAP unit test. But you will do it later on into the system, in the system. So today's example, the application is a travel list report with filtering, search and draft capabilities, and yeah, with a list report page and a detail page. The data model we are using is the Fly data model, a reloaded one. So it is a bit similar. If for those coming from the NetWeaver world, you will know about Fly data model, but this is a new one, a reloaded one that we typically use in the RAP area to provide examples, but it's on the ABAP. You can use it also for other technology on the ABAP platform. And here our main entities are travel entities, travel and booking entities. And then we have some other associations to customer, agency, in flight. So having said that, I'm handing over to you, Volker, for the demo.
Yeah, thank you, Karin. Thanks for the nice introduction into the topic. I will quickly share my desktop. So yeah, hello also from my side. As indicated, this session is about the Dev 260 TechEd session that was conducted as a workshop in last year's TechEd. And the entire content of that hands-on workshop can be found on the GitHub repository. And it's fully self-contained, so you can run the session entirely on your own. The session aims for making use of the ABAP trial environment that you can just access by requesting for a user there. So there's this trial environment on SAP Cloud Platform, and you can just create a trial account. That is free of charge. And with that, you can also make use of one ABAP instance. It's a shared instance, so you are not getting your own individual ABAP environment there. You share this with multiple other people. And as such, yeah, of course, you should always be careful with creating and changing stuff. But yeah, typically you work in your own package, and therefore that is not that critical. So this is all explained in the hands-on session here that we have outlined in this GitHub repository. And as indicated by Karin, the purpose of this session is to create a draft-enabled Fiori Elements application that is based on the travel example that we also use in our RAP documentation. So you will find the same entities, these travel and booking things and agency and so on in our documentation as well. Since we make use of that, and the demo content is built together with the documentation colleagues. And when they create the documentation, and to make sure that this is fully in line. The application itself, I have already started it here because I've prepared it in one package. And by the way, I hope the resolution is okay, because on the left-hand side, I would like to keep the browser window open, because I will, like you are supposed to do in this session, you will, and I will take over and copy over the snippets that are highlighted there. And on the right-hand side, I have my ADT, my Eclipse environment open, where the actual things then are implemented. So the resulting application looks like you can see here. Let me quickly refresh to make sure that there was no timeout. Yeah, it as said works or runs on the ABAP tile environment, so that yeah, it's very, very helpful. So there's no big installation need on your side. At least, I mean, you only need to have the Eclipse tooling installed, I think, and then you simply apply for access, and then you should be good to go. The application itself, yeah, starts with a list report that I think you also know is the traditional or one of the most common ways for the Fiori Elements applications. It has a filter bar up there. You can just also click go in order to execute and yeah, issue a query without a filter. Then you get the set of travel records here. These are the header records. You can click inside one, and then with the one-to-many relationship, you see that there's a few header attributes, and underneath there is a set of bookings. In this case, there are 2 bookings. So this is the pattern of this session here. We will build this from scratch, as also said by Karin. It's a greenfield application. So this means we start by creating the database tables, although I've already prepared a few of these things that I just take you through in order to save some time here. But the session itself, if you go into it and click through the steps here, and I quickly scroll down, you really start with the getting started, where you log into Eclipse. You make sure that you have access to the trial account. You create yourself a package, and where you implement all the things. Then the next step is you create your own database tables, yeah, where you also use a little helper class kind of report, but in the cloud environment there are no reports anymore, so you need to run a little ABAP class in order to pre-populate these tables with a few data, so that you don't start with empty data or empty tables here. Sometimes I feel this more a bit nicer if there's already some stuff in there. Then very important, the CDS data model will be built. On top of it, we will have the CDS data projection, and we make use of the metadata extensions to make sure that the UI knows which columns to show, which fields to show on the object page. So these first 4 steps or exercise steps I've already prepared, and I will quickly take you through the details. Just as a little reminder here, in case you have any questions, please feel free to ask them. The colleagues will take a look at the Q&A part and try to answer these things right away. If that requires maybe more time or things that I need to show, then yeah, we will maybe also take a few questions then at the end of the session. Okay, yeah, then quickly let's take a look at the details. As said, I've already prepared a few things here, absolutely identical to as indicated and described here in the exercise description. So I've started by creating the 2 tables that will hold our data. It's the travel table and the booking table. As said, it has a handful of fields. Important here in this scenario, we make use of UUID as the key. This is yeah, more or less the recommended approach at the moment for the so-called managed implementations, as we don't yet offer the according exit for implementing so-called early numbering, which you would require in a managed scenario, especially with draft. There's also workarounds available so that you can also make use of a semantic key scenario. But with the next release, we at least plan to offer this so-called exit, this user exit that you can implement in order to also make use of a semantic key scenario, where you typically would then use maybe a number range object to draw a key. In this example, as said, we keep it simple in the sense that we have a technical key on the database, but still next to it, we have a kind of human readable key, which is the travel ID that allows you to kind of grab the data in a better way. So looking at our application again here, as you can see, we have a kind of understandable travel ID 200, but then the technical key is also shown here, and this is just for the kind of exercise purpose. Of course, in a real environment, in a real app, you would typically not show a GUID, a UUID to the end user. This is, as I said, just for the demo purpose here. So the table I can quickly execute. As said, I have already pre-filled it with some sample data. This is simply copied over from the existing tables, and this little class that is used here is also part of the steps that you execute when setting up the environment as described in the GitHub repository. So this is the travel table, and there is also then the booking table where the with a one-to-many relationship booking records exist. It also consists of a UUID key. It has only a single key because the UUID itself is single, already unique, but it also needs and requires a key or the ID to point to its travel header, and then all the kind of regular attributes, I would say, that are also shown and visible in the UI. Okay, yeah. Then the actual data model that we require for the RAP business object is outlined or defined in CDS views. So let me quickly close these two screens here and open the I view. So here we stick to this, more or less naming pattern, I would say. That the views containing the I underscore, this I stands for interface views. These are the kind of BO views or the transactional processing views. Maybe some of you might know that pattern from the Fiori programming model, the former programming model of the RAP programming model. And there also I views were used for the TP layer, for the transactional processing layer. So these I views, they form the foundation of our business object, and they define basically the structure, the composition hierarchy to be precise. And that is what we see here. So we define the root view. So this is one new keyword for those of you who are already familiar with CDS. You might find this as a new keyword here. It's a root view. So with this statement, we precisely identify one entity, in this case, the travel entity, as the root of our business object structure or the composition hierarchy. Then we make use of view entities. That is a new paradigm. It's a next generation CDS view mechanism that are kind of a bit more efficient, I would say. They don't have this SQL view anymore. So things like that you had to specify in the past as well next to the view name. So I would just say kind of the new way of defining CDS views. Then we have the actual select from the database, and with the in the association part, we have the regular associations that you also might know from the past, where for instance here the agency customer associated tables are listed. But more importantly, we have a specific composition information here where we define the structure as set of the business object composition hierarchy. And here we, with that, we also make this a one-to-many relationship in terms of the cardinality, so that there is the option to create multiple bookings as part of one travel, like in a sales order header and line item setup. Okay, other than that, we have a few technical fields that we also recommend to add. So we have this created by or last changed by. So this will reflect the username who has created the record and who was the one who last changed it. There are two or actually three additional timestamps. There is when the record was created, when the record was last changed, and for the handling of the managed environment, we also recommend to add a specific local last changed at. This is especially needed in combination with the regular last changed at, also in the context of draft. So therefore, we on that environment, we need this to identify changes that are done to the active record while the draft log has expired. So if you are a bit familiar with draft handling, you might probably know that draft works with so-called durable logs. That means although the HTTP protocol is obviously stateless, there is a state kept in the backend, which is actually the log. So while you edit an instance, there is a so-called durable log in the backend, and that protects your instance, your travel or your sales order or your purchase order from changes done by others. but this log is this durable log is not as durable as the name indicates, because it makes obviously sense to not keep such logs forever, because at a certain point in time you also want to remove those logs, to make sure that somebody who goes on vacation or so is not logging an instance for several weeks or even months. So these durable logs, they expire. And if they are expired, then still this draft information is there. But when they are expired, then of course somebody could make a change directly to the active instance. So you know that draft creates a copy into the so-called draft tables, and you work on this copy. This means everything you edit is not yet visible to the active persistence. This means has no impact or has no influence to any other selections or any other post-processing steps. You're kind of isolated, working in a isolated environment, unless you activate your record. And so this draft instance would also remain there in this table, also for a given time. I mean, there's jobs that cleans such outdated data, cleans them up. But for the time being, or for that time window in which these draft instances exist, it could theoretically happen that somebody wants to continue to edit his draft that has expired maybe after half an hour or so. And these timestamps are used for identifying such situations, so that in case somebody has in parallel changed the active instance directly, because although you are in a draft enabled environment, it does not necessarily mean that you always have to change the instance using the draft, but you could also do updates to the instance, to the active instance directly. So it's a little tricky, I know. There's very comprehensive documentation about the entire programming model, but also, of course, on the draft topic and this timings and these durable logs and everything. So this is explained there in detail, and that is the reason why these timestamps are there and why they are added. The booking and CDS view looks like the following. So it's also, again, a CDS view entity, but of course, since the booking iView does not reflect the root, it doesn't carry the keyword root here, and it has a regular association to its parent. This is kind of both are pointing to each other, and by that kind of defining that composition hierarchy. I think that's it mainly here for the booking TP view. Then on top of the transactional processing view, we then use for typically each consumption scenario, we create a projection on top of it. And that is also recommended or strongly recommended to always make use of the projection, because the projection simply allows you to also add further capabilities to the underlying business object while your projection can remain stable. Of course, I mean, it depends on what changes you do. If you remove a field, of course, it cannot be stable. But typically, if you add more fields or add more actions and things like that, then the projection typically can remain stable, and you can further enhance and implement your business object while the use case or the exposure scenario remains stable. And the projections are defined as follows. They also make use of new keywords. So technically, it's again a view entity. The travel consumption view is again a root view, as it reflects the root node of the business object hierarchy, and makes use of the as projection on keyword. And by that, the view is of type projection view. So it's a specific CDS view type here. Again, similar to the other view type, for instance, it doesn't require an SQL view, allows you to, first of all, define this projection model. You can also, for instance, make text denormalizations like here, where you enrich the data model that is exposed with, for instance, here the name of the individual agency or customer. That could even be language specific, which is not covered in this example, but in the documentation you will see the full-blown examples that also comes with a third node. So it doesn't not only consist of travel and booking, but also has a third level, which is called booking supplements. And there, for instance, you would find a supplement or an extra that you can book on top, like extra meal or extra luggage. And that then also comes with a text denormalization with a language-dependent text. Another aspect to highlight here is when you expose or inherit the associations from the underlying view. So you know that pattern probably when you define a view on top of another view, then you typically inherit the definitions or the attributes. So for instance, if I just name here the association section, if I only simply name here, for instance, agency, then I inherit the agency association defined in the underlying CDS view. But in case of the composition hierarchy, I do not want to actually inherit the one underneath, because for the booking, since it is part of my composition hierarchy, I want explicitly point this also to the corresponding consumption CDS view, to the corresponding projection view. So therefore, I need to redirect this one, this inherited one from the I layer, to the one pointing to the C layer, so that I have this kind of belonging together, so that in the projection layer I also make use of the respective projections. So this is done in the travel entity pointing to the booking composition or the association. And if I look at inside the booking CDS view, I find a similar pattern where obviously the booking has to point to its travel. To be precise, it has to point to the individual level above, as well as always to the route. In this easy example, we only have 2 nodes. Of course, there is not that many associations that you need for the composition hierarchy. Yeah, but in a more complex business object, you would find that. And here it's the same pattern, that in this with this travel association, we also need to make sure that we point to the corresponding C layer, and we do not want this inheritance, but instead we redirect these things. Okay. Furthermore, you see that some value help definitions have been added here, some at consumption annotations. Also the search annotation was used here, so I will not dig too much into these details. They can also be found in the documentation, or in case you have specific questions to that, then just raise them as questions. Then last but not least, the metadata extension. I think that is not too tricky one. Let me quickly close these tabs. Always takes a second. My laptop is not the fastest one. Similar again, we have the same pattern here, one metadata extension for the travel entity and one for the booking entity. And they define the UI annotations for the respective consumption views, because this is our consumption scenario, that we define a consumption, a projection for a particular UI use case, which is our Fiori Elements list report application that you have seen. Then it's a regular pattern here. You define the facets that allow you to specify, okay, this is the object page. It is pointing to the list of bookings, and then with the UI identification and line item annotation, you specify the fields that are shown in the list report columns, as well as on the object page. So there's also no real magic here. Maybe a little magic that I can highlight here, which is the selection field, or the ability to filter for fields that are not part of the node itself. So it's not, we can, for instance, in OData v4, this is not supported in OData v2, but in OData v4, it is possible that you also define, in this case, a filter for an element that is only accessible via the association here. And that is one of the features of OData v4, that you can specify this in the UI. The OData v4 Fiori Elements UI also offers this for you. Okay, so this is basically this little preparation, and looking at the time, it was not really little, but these are the steps that are depicted here in the first 4 exercises. The 5th exercise, business service, is now the one that I will now start looking in detail, because yeah, as supposed for you as a participant of the Dev 260 session, you would yeah, go through the steps and build these things as depicted here. And I will quickly do this. Let me close this one. So, and while I do this, I try to explain and things. So what we create now is the service definition, and you've seen this in the big picture that Karin has shared with you. So we have now, we have defined our projection view that defines the projection that we want to expose. And in order to make this an OData service, we first of all need to specify a service definition. In the service definition, we list all the entities that we want to expose. I give this a name. This will be for a UI use case. So therefore, this little UI indicator is in here. You will see when you look into the exercise description that you're supposed to define a group ID, a 4-digit group ID for yourself to make sure you do not interfere with others. I have chosen this VD02 because, yeah, of course, practice this before the session in VD01. And of course, you need to make, you need to cross-check that this ID is not used already. Accordingly, I also have created a package in which I have created all my artifacts here. And you see this pattern that this VD2 is used. I'm using here throughout the entire steps of the exercises. Okay, so I've specified here my data definition, or right-clicked on it and said, okay, I want to have a new service definition, because the service definition lists all the artifacts that I want to expose in my OData service. So I scroll down here while the editor is opening, and I will make use of the prepared stuff here. So like you do in this session, I will just replace that here. And this pattern is also very common. You will see that across the entire set of exercises, that you copy these things over. So a lot of stuff has been prepared, since it's quite a lot of stuff to really make a fully functional transactional business object with validations and determinations and these things. So a lot of things have been prepared up front, and you just copy them over, and then yeah, you can take a look at the details and how these things are implemented. There's actually not much need of typing a lot of stuff in yourself, but you mainly copy and then replace these placeholders with the individual group ID that you're using. So I will do this as well. I will replace these 4 hashes with my the group ID VD02 that I've chosen. Okay, and after I've done that, then the errors should have been gone, and I can activate this artifact. And with that, I've defined the set of entities that I want to expose. You might wonder why these others are listed here, because they don't belong to the composition hierarchy. Actually, they are not needed, so they would be pulled in automatically since they are used in value helps. So they would come more or less for free. We use them, and you will see that in our examples that we explain and show in the documentation as well. And we make use of that because we want to rename them, since in this particular environment, the artifacts that we provide in the documentation and in the sample code, they make use of a namespace, and this /demo namespace that we use here is not compatible directly with the OData notation here, and this means these slashes need to be replaced, and this looks a bit ugly or strange when you just expose them right away with this automatic replacement here. Therefore, we use the exposure here to give them a better name. But this is technically not needed. I could just remove these ones. Important is only that the travel and the booking, the composition hierarchy is listed here. Okay, so we have done that. Next thing is that we create a service binding, and Karin also mentioned that. So far, although we have seen this little speciality that in this CDS view or the metadata extension, we have made use of an OData v4 feature, but actually all the things that were done so far are completely independent of the OData protocol. Yeah, so it's really the more or less the last mile when we, in terms of the stack and the hierarchy here, when we add the service binding. And that is done typically via a right click. So we make use of the context menu very heavily. So you right click on the service definition, and then you select new service binding. We give it a proper name, make things easy, just copy the pattern over here. and say VD02. Give it a meaningful description. Okay, for travels, and then you select the binding type. So it's very different compared to, for instance, the Gateway Service Builder that you might know, where more or less when you started to create a project, you already had to specify what OData protocol version you wanted to create, and according to your what you've chosen there, according to your choice, you had to implement it accordingly. And here, this is totally different with the RAP programming model. You build the business object structure. You implement the behavior. We have not done that yet. This will come. And then when you expose it at the very end or the latest point in time, you actually specify the protocol. And this allows us as the platform to add, for instance, new protocols in the future. And then without any implementation effort on your side, you can quickly make use or easily make use of these new protocols, and you do not have to implement your OData service again from scratch. Yeah, so I think that's also very good, big benefit here. So we chose OData V4 UI since we want to go for a UI version. That means also that the value helps would automatically be exposed, which is not needed in a web API service, for instance. Okay, choosing next, choosing finish, assigning it to a transport, and then we need to activate it. So this is also a new feature that the service bindings now need to be activated, and then we can publish it. Publish means the publishing takes place locally. It is not meant for the productive publishing, but this is just for the developer working on this system and other developers. So this means everyone who has the developer role in the on that Steampunk system, on this trial environment, is able to, of course, see your artifacts and also access and open your service. Yeah? So it's not meant for a productive environment where you have dedicated users that via role assignment will get this app and will also get the authority to execute the service. This is done here differently, or no, this is simply a different role now as we work as a developer here. We have the ability to publish it locally and then have easy access to it without the need to role assignment and things like that. Okay, so it has now been published. I can open, for instance, the service URL directly. I most probably need to log in again because I'm pretty sure that it has expired. So I use a private email address here. So to make sure that this is really comparable with the trial environment that you can access. So there's no kind of magic with my SAP user or so. So this is the service document. On the OData V4 side, this looks a little leaner. It's a JSON representation, and you can also just add $metadata, add it, and then you see the more or less well-known metadata file. Another very important and very cool feature is the so-called OData Preview, or Fiori Elements Preview, sorry, that we offer here. Because instead of now setting up a UI project, maybe with the Web IDE or with Visual Studio Code, which you can do as well, you have the ability to quickly run the application with the already defined annotations. That's also the reason why we make use of the UI annotations on the backend. So because to specify the fields and columns and everything that we want to have on our UI. And so this backend UI driven UIs can then simply be executed without the need of a UI project. And this we can trigger by using the preview. So either you just mark your entity that you want to run and click preview, or you can also double click on it, and then it opens the browser with a manifest file that is generated on the fly. And if everything goes well, then as you can see here, the application comes up and I have my list report application. So it uses the generated data. I can drill into the object page, and based on the UI annotations, I see my details here. What is not yet in, and this is what we are going to add now, is the transactional capabilities. So because I said we built this more or less from scratch, so far we only have the data model We have the database tables and we have the structure, but we have not yet implemented any business logic. That means we cannot make use of any transactional capabilities, but this will come now. So I close this one. I also close that one because this was the one that I created before. And now we continue with the exercise. So we have created a service binding. We have published a service, and we can preview the app. So this is all highlighted here in the documented exercises as well. The next thing is the business object behavior. So this starts now to inject actually live into our business object. So again, making use of the kind of forward navigation or context menu we create for our root CDS view, and this is for the base CDS view, we create a behavior definition. The behavior definition is a new repository artifact that was introduced with RAP to explicitly have an artifact containing the behavior that is part or this that this business object covers. In the past, those of you knowing the former programming model know that this was done with many object model annotations in the CDS views. So there you would, for instance, have like specified the persistent table or any draft table and a draft environment and so on. So this has moved now into a new repository artifact, which is the behavior definition. When you start creating the behavior definition, you are asked for the description. You can typically leave it as it is because it is defaulted, as you can see here. The name of the behavior definition has to be identical to the name of the CDS view, of the root CDS view. So there is no option to change that one. And what you can choose of is the implementation type. As this is a greenfield implementation, so we don't have any legacy logic. There's no need for implementing any adapter, but we can directly write into the specified database tables. We, of course, go for the managed scenario. And this is definitely the recommended approach. So whenever possible, and you have kind of control about the tables that you are updating and writing your data into, we recommend to make use of the managed scenario, because then a lot of things are taken over for you by the framework, and you have dedicated kind of exits or entry points like validations, determinations, actions, where you then can add your specific logic. And this is what we will do here as well. So we choose this, we assign it to a transport as always, and then we have here our behavior definition for this managed business object. Again, I will make use of what is highlighted here in the script. So we will now copy over the actual definition. So first of all, it's already a managed BO. This is fine. But with this addition with draft, we allow, or we basically enable this business object to become or to be a draft-enabled business object. That is, by the way, also a feature that was recently introduced with 2008, 2009 for the cloud as well as for on-premise, that we offer now the draft capabilities. So the next thing is already there. We have the defined behavior statement. We need to specify an implementation class that holds our business logic. We need to specify a persistent table that will be used by the framework, by the managed runtime to update the data directly. And since this is a draft scenario, we also need to specify a draft table where this kind of shadow records are stored. So as said some time ago, the draft instances that you work on are persisted in a separate table, which is kind of a copy, more or less. You will see that when we look at the structure. And in this copy, you work as long as you need, and then once you're done, then only these changes are copied over and taken over into the so-called active persistence. This is, by the way, also this little letter that we use here. This little A indicates that this is a table that carries the active records. So this we make use for both the travel data as well as the booking data. That's the reason why we've added this little A in front, and you can guess the D stands for draft. So these tables, they carry the draft data. This e-tag handling or these timestamps, I think I've explained before. So this total e-tag is needed for this concurrency control in terms or in case of expired drafts when changes are made to the active persistence directly. And the regular e-tag, that is maybe something that you might know from the OData world, is used for the optimistic concurrency control in the UI, that if you accidentally maybe, for instance, have the same instance open in multiple tabs of your browser, that you don't overwrite things with these multiple sessions. Okay, so we take this over as a first block. And then we continue with the operations that are allowed. In this case, we offer all operations, create, update, and delete. Also, we offer the create operation with draft support for the bookings. That is the association. So this is also something we can take over here. Most of the stuff is already there, but for completeness reasons, just do it this way. Then we specify some fields where we do so-called static feature control. This means we define certain fields, for instance, here as read-only, like the travel ID, so the human readable travel ID, the price information, and of course these admin fields, they are set to read only because we don't want the application to change them because they just changed internally inside the BO. A bit special is maybe here the UUID, the actual technical key of our business object, that is the travel UUID. That one we make, of course, also read-only because we don't want anyone to change the UUID. But more importantly, we make this numbering managed. That means that the UUID is calculated by the managed environment, by the managed runtime when a new record is created. So we don't need to write a single line of code for calculating or creating the UUID. This is done by the framework. Mandatory can also be specified for fields, but here a little kind of warning or information in addition. It only brings this little red star to the UI. It is not providing automatically out-of-the-box validations so that these fields are actually filled. This is something you, in addition, need to implement via a validation. Okay, we take them over. And then we have something that I think from a tooling perspective, we need to improve probably, which is the mapping information. The mapping information is needed in case you have chosen different names between the persistent table and the CDS use. Yeah? So in our case, we have renamed the fields slightly. This was not done because we haven't really taken care of, because this happened on purpose to highlight this feature and to make you aware about it. In this case, it was just removing the underscore and making this camel case, but theoretically, you could also name them completely different because these are the database table fields that you map to your CDS use, and you might also know that the names of the database table fields in terms of length is more restricted than the ones that you can have in CDS. So therefore, you're more flexible, and you would typically choose different names, for the elements here in your CDS use, and therefore this mapping is typically required. In this scenario, it would wouldn't have been necessarily needed, but we have added it here just to point this out, that this is in most of the cases required. So this mapping information is needed so that at runtime, when changes to these entities, to these instances are happening, so that the framework knows how to update and how to write things into your persistent database table that you have specified up here. So the name is clear, but the framework needs to understand and know how to map these fields. Also, very common pitfall is when you have a running application and you add a new field, a new element to your database table and to your CDS use, that you might miss to add this mapping here as well. And if you don't map it, it will not be updated. This means you might wonder that you do changes to your specific field in the UI, but when you activate your record, these changes are gone. And that is typically a candidate for a missed out mapping information here. Okay, so this this is the information for the travel node. Yeah, so this entire block here is for the travel entity. We have a similar block for the booking entity. So this one I will also quickly take over. I could just take it entirely over, then I don't need to do that multiple times. I will quickly explain again. So the booking entity looks very similar. So here with this statement, we define the booking as a node in the composition hierarchy, pointing to the respective CDS view that defines the structure. We also specify an implementation class. We specify a persistent table where the data is supposed to be written into, the draft table as well. A little difference here, log dependent. So I did not talk about much of this up here. So we have a log master. That means we define a log shadow, to phrase it that way, where you have one node, and in this case, currently there's only one root node allowed. One log master allowed. This has to be identical to the root node. And underneath, you can have multiple nodes making use of the same log master, of the same log shadow. And in order to point to the corresponding root node or to that log master instance, an association is needed. And you might remember that in the booking entity, we have specified this association to the travel header, to the root node. And with this statement log dependent by, we can more or less make use of this one or reuse this association here for defining or for letting the runtime find the corresponding log master to actually log the record. So what does that mean in reality? When you do, for instance, with OData, a direct update of a booking, which you can do, then, of course, in order to log the record, the corresponding log entry needs to be found, or this corresponding log master need to be found. And this is done by the framework understanding and interpreting here this log dependent by information. And similar to the ETAG that we have specified up there, each node, if possible, should have an individual ETAG master, because then you can also specify changes done on this individual node. It is not the case that changes to a subnode reflect as changes to the corresponding header, because then, of course, you can easily run into ETAG conflicts. For subnodes, we typically only define update and delete, because creations are typically done via the so-called create by association. Yeah? So a direct create on a subnode in the managed environment is not possible and not supported. That is coming via the association, via, in this case, the booking association and the create enablement here. So this is basically the create that creates records in the booking, which happens on purpose to make sure that the create is directly or always happening via the corresponding travel and record, and not directly to the booking, to the list of bookings. Yeah? So it always has to have its context. That is very important. For the unmanaged scenario, this is also the recommended approach, although it is technically not necessary. But if you want to make use of draft in the unmanaged environment, you are more or less in the same situation. So therefore, it's a good advice to not offer the direct create on the sub-entity or on a subnode, but only via the create by association. Okay, same situation here with the fields, with the static field control. We specify numbering managed in order to calculate the UUID for the booking record. We also set it to read only so that it's not changed. Same is needed for the travel ID. That as you've seen in the data model, that the bookings are pointing to the corresponding header record, to the travel record. And with this read-only annotation, also the framework understanding and interpreting the on condition that you have specified via the association, the framework also automatically fills the travel UUID of the subnodes. Yeah, so this is also something that you don't have to implement yourself. Okay, so now we are done with copying things over. What I need to do again is I need to do search and replace. So to replace these placeholders with my initials that I've chosen for this exercise here. So, and after I've done that, then we see a few errors still there. They are reflecting or pointing now to the missing draft tables. The draft tables, as I said, are storing the draft records that are needed when you edit any instances. And you see here that the draft tables have not yet been created because we only have the active tables. The good thing here with the RAP programming model is that you have full control about the draft tables, and you typically create them using the tool support. This means you use the quick fix here. Should work actually, maybe, okay, take it here. I'm using the quick assist here to let the draft table be generated by the framework. And this also works for updates later on. So I let, based on the definition of the CDS, of the data model, based on this definition, I let the framework generate the draft table definition for me. So this is done now. I can just kind of blindly activate this one. So typically there is no need to edit it, but we still open it in the editor so to give you control, because in the past we have silently generated it under the hood and even had specified a lock on the object so that you could not even modify it yourself. But that has had impacts on life cycle aspects, and we learned that this is better to be under your control. So it's a regular repository object that you can even change, delete if you want. But of course, if it is not present, you will be highlighted by a corresponding warning or error message that this is missing. Okay, so I do this for the travel entity as well as for the booking entity. So same here. Okay, yeah, the quick fix is working. It was maybe too slow. So I create this one here as well. Assign it to a transport request, click finish, and then this draft table for the booking entity is generated for me. And I said it is identical to the structure of the CDS view. So it's not identical to the structure of the database tables for the active persistent, but it uses the structure of the CDS view and uses a general admin include that is needed for letting the framework handle the draft specific things. Okay, so this was done now. Let me quickly update here. So now you see the errors are gone. We can activate the behavior definition. And what is left now is that there is only 2 warnings left, indicating that my implementation classes are not yet present. Yeah? So they don't exist since I just specified the names, but I have not created them. Again, we can make use of the quick fix. Here we can let the framework help us in creating the behavior implementation classes, at least the stubs. So this means the method declarations as well as the empty implementations. And this is what we need for the time being. So let's just activate this class here. The same I do for the booking node. There is actually no logic that needs to be generated here. So it's basically an empty class that we will generate. Again, making use of the tool support. And once this is done, I can also activate this one. I said this is on purpose, it is empty yet. We will fill that soon. And when I now check my behavior definition, then also these 2 warnings are gone. So now let's scroll down. So this is all also briefly explained here in the script that I've prepared. So about these fields, eTech master and everything, you can just check on your own. And also again, very strongly recommend the links that we provided into the RAP documentation, where these things and topics and patterns are explained more in detail. Okay, so we have created a draft table, we have activated them, we have created the behavior implementation classes where our actual business logic sits. Next thing we do is we create the behavior projection. So similar to the CDS model, we can close these things here. Similar to the CDS projection views, we also project the behavior. Some of the behavior that is defined in the underlying business object does not need to be projected. You will see that later on, for instance, for validations and determinations, they are also, they are always automatically there. But for instance, actions and such things, these are need to be projected to allow them in this particular use case or not. The BO projection will be created again by right click on the corresponding root view. This time we choose the projection route view, the consumption view, and again we choose new behavior definition. And this time the implementation type is already defaulted to projection. So the tooling has looked inside the CDS view that I've specified here and has identified that this is a projection view. So this is very likely to become a projection behavior definition because nothing else makes sense in this context. And that's also the reason why nothing different can be chosen here. So again, choosing next, assigning it to a transport request. And then we have our projection behavior definition. So we scroll down. So here this time there's not that much that we will take over. It is similar as before. We also project the draft capability. I think this is also a very cool feature, which means that you can specify or define a draft enabled business object, but for a specific projection, you don't offer the draft capabilities, but you only as such then allow changes to the active instances directly. What you here also specify is the usage of the e-tag. So you can specify if you want to make use of e-tag in this respective node. So the e-tag choice is taking place per node. And also you specify the usage, the allowance of the corresponding base operations, create, update, and delete, as well as the association where you also see the create operation here. So this is what you specify in the projection BDEF in our simple scenario in our case here. Again, same as before, I activate this. And if now I reload the application and everything went well, then I most probably need to log in again because I've talked a lot and it might have timed out. No, it hasn't, so it's still valid. Then we now see a create button and a delete button, and we could also edit existing records. So we could, sometimes it takes a little while in the cloud until all the buffers are updated. So now it works. So this is also something that we work on, that in the app servers on the cloud environment, the trial environment specifically, that the sync times are reduced so that the changes are reflected quicker, because sometimes it happens that it takes a while, and I think maximum up to a minute until these changes are reflected. And so sometimes you change something in the backend and you wonder why it is not working in the UI, but then it might simply be a timing issue and you just need to wait and be patient. Okay, so we can jump into records and change them. We can also create records now. Just be aware, we have not yet done any business logic implementation. We have just specified a few fields in terms of static feature control. So for instance, the travel ID, we have set to read only. The UUID, we have also set to read only. So, and here, by the way, you see the calculation that is done by the framework for you. And the mandatory fields are highlighted with this little red star symbol, but nothing beyond. So that means we can more or less type in what we want and can just store the records, as there is no yet any validation or things like that. We will add that in a second. So let me quickly cancel this one so that we move on, because I think timing-wise, I need to speed up a bit, because otherwise we might not be able to finish everything here. Okay, so this is the preview, and at this point in time, you can already start playing around. Create, update, and delete are working, but I said no validations are there. So the first thing we add in terms of business logic implementation are actions, and this is in exercise 7. Opening this one now asks us first to implement actions. So we specifically now need 2 actions. We already will take care about a third one, which is a so-called internal action, so kind of a private action that will be used in a subsequent section of this workshop. So let's quickly add these 3 action definitions. The 2 actions, the first ones, which is accept travel and reject travel, are supposed to, as you can see, maybe quickly here in the UI, we have this overall status. And with these actions, you can change the status, because the status is also set to read only. And you can, O means open, and you can set the status to A like accepted, or X, which stands for rejected. And this is what these actions are about. And this is what we are specifying now. So when we add these two actions, actually 3 actions, when we add these actions, the tooling identifies that there is no corresponding implementation yet available. So it helps us again, clicking on this little bulb here, that allows us to implement all these 3 actions in one shot. Yeah, that technically means it's not really the implementation, but it's again the stub that is generated for us. So it generates the method declaration and an empty implementation for us. Yeah? So now I could start typing in, implementing the accept travel method that is then executed when the corresponding action is clicked on the UI. Again, in order to speed things up, we have prepared this. So the pattern here is that code snippets again will be used. And I'm just taking over the snippet that is here, which contains implementations for all these methods. You see it's a little lengthy. That is mainly the reason because this calculate total price is also contained, which is needed for a recalculation of the total price, that when things are changed either in the bookings or in the booking fee, that then a recalculation is possible. So I will quickly replace that here at my initials here, and then the implementation hopefully does not contain any error anymore. It does it in this case. Why is it doing this? I know, because I forgot to activate my behavior definition. So this means the BDEF needs to be active so that the corresponding class or the syntax check, which takes place on the fly, can recognize if this is valid or not. So now the error is gone. We can quickly look into one implementation to simply make you aware about what is going on here. So first of all, we make use of the so-called EML entity manipulation language. It's a built-in new ABAP language set that allows you to interact with business object instances. Yeah, so instead of maybe updating an internal buffer or calling any public classes or so, we have built-in language support here, and that looks like, for instance, in the following, that we have, in this case, a modify statement, a modify entities statement that allows us to interact with a given entity, with a given business object. In this case, it is our own business object, therefore we can call it in so-called local mode that skips authority checks and other things. But we could also talk to any other business object that is defined in the system. So it could be a sales order, procurement business object, whatsoever. In this BO, we specify the node that we want to talk to, and then we more or less have an operation or a verb here that we want to do an update. And in this particular case, we want to update a set of fields. It's a single field in this case. It's a travel status, and we do this now for a list of keys. So what we receive by the framework, and this exit is called by the framework when the corresponding action is triggered. What we receive from the framework is a list of keys for which this operation or for which this action is supposed to be executed. Yeah, looking at the definition, and by the way, I'm using this element info here because I find this very, very handy to have it here right away in this as a view open. You could also just mark an element here and click F2, and then you also get this element info about this element. Yeah, so you see it's a table. So the entire RAP framework, as well as this EML entity manipulation language, is mass enabled. That means it allows for mass operations. And so we get a list of keys, and most of the cases, especially in UI cases, it's only one record that we get, but it could be many. Especially when somebody else calls you via EML, he or she could pass as many keys, as many values as he or she wants. And therefore, it makes sense to also implement your handling of the corresponding actions in a mass-enabled way. And that is done here. We use this value operator to create a value, to use, create a data type on the fly that is corresponding to what is expected here. That is indicated by this hash. And with this for loop, we make sure that the output of this, that the result of this one is a table. And the table makes use of a key. It's a so-called transactional key we introduced with RAP, so-called built-in types with named includes. So they are identified by these percent fields. So most of them are identified by these percent fields. And looking at the code completion, you see there is a set of these percent ones. You could identify or make access the key of the corresponding instance by using the percent key, but this is just a key that you specify in the CDS view. The T key, that it stands for transactional key, that is the one that is used in the draft enabled scenarios. So it also, next to the regular key, it also contains the is draft indicator, and therefore we make use of that one here. Yeah, so we specify that for this key, we want the travel status to be updated to this new value, which is the accepted value. Yeah? So this is a constant that we have specified here. Yeah, and as a result of a modify execution, there can be failed keys. That means keys that were not that didn't work. Yeah, it could be an instance that doesn't exist or something like that. And corresponding to these failed keys, there can also be reported entries that tell or talk about messages, T100 messages that might have raised during the processing. And what we also need to specify here in this action, so we modify the instances, we update the status field, and in order to let the UI right away fetch the updated values, we make use here, we specify the result in the sense that the updated values are already passed back so that these changes are directly reflected. Yeah, this is how we implement this action. So let me quickly also activate this one. I have not done this yet exactly. Then again, following the pattern here in the script, we also need to make, so we need to adjust the projection so that we allow for the usage of the two actions here. I will quickly do that. I will add them here to the association. Again, very slow on my side. Okay, activate this one. And last but not least, since this is UI, has a UI relevance, we also need to make sure that the buttons are visible with a corresponding label, that they appear on the UI. And for that, we need to update the metadata extension. And that is done down in the that there is these commented lines that we just need to remove, and they will add the corresponding buttons to the UI. So if that was activated properly, and if I'm lucky and the refresh to the UI goes quickly, then these new actions should appear on the screen, keeping fingers crossed. Yes, they do. So you see reject travel and accept travel. And with that, I can now mark any record here, for instance, this one, which is in status open, and I can say that I want to accept this one. So, and this navigates me automatically to the instance here, to the object page, because of the result that we have specified. So reading the actual value. You might have noticed now also that the accept button is now grayed out. It's not active anymore. This also came a bit under the hood with the implementation of the get features method. Yeah. So while copying over the prepared source code, also the get features implementation was added, and the get features implementation takes care about the actual feature. So this means you have a so-called dynamic feature control that allows you for dynamically change the features, allow or disallow them based on the current status of the entity. Yeah, so the feature implementation again makes use of the EML statement and now reads the current status of the entities. And based on the current status, we then decide whether it's allowed to click the accept button or the reject button. So simply it means if the status is accepted, then the accept button is turned off. And if the status is cancelled or rejected, then the reject button is off. Yeah, very simple logic here. So this means when I now click on reject, it should toggle to X, which stands for rejected, and now the accept button is on. So this little dynamic feature control or instance-specific feature control is established via this get features implementation. Okay. Yeah, then again, the preview you can use. And next thing is determinations. When you want to do some, for instance, some defaulting of any values, you typically implement determinations. A very classical determination in this case would be that we calculate the new travel ID, the alternative key or the semantic key, or for instance, we want to default the overall status. When I now do a create without a determination, you see the status is empty and there is no travel ID. And this we will change now with this implementation. What we add here is we add this determination that take care that we want to, let me close these screens again, that are triggered on a certain point in time. And there is one that takes care for setting the initial status of the travel, which is the status O. And that is happening already when the create is taking place and at the time when the modify is happening. There is two more or less points in time when these determinations can be executed. It can be on modify, that means right away when a UI change is happening, or on save, that means when the activation is taking place. Yeah, you see that the calculation of the travel ID happens when the save is happening. The calculation on the total price I need to skip now because of timing reasons. Again, we can make use of the tool support to generate these method stubs for us, so that they don't need to have written down at least a declaration of the methods as well as the empty implementations. This is something that is done for you. We take over the implementation that is prepared again. So if you scroll down a little bit, then you see again this class implementation, and that I simply take over and I make use of the raw visualization and copy that. As said, due to timing, I cannot go that much into detail now. We'll just quickly do that. So for the travel instance, I need to replace this here. So for the travel instance, for instance, let me do the, again, I missed to activate this. For the setting of the initial status, very similar to the action. In this case, we read the current status, and only for those records that do not yet have a status, we set the status. That is again with this EML statement. So EML can make use of read and modify, and there's a few more, but these are the main operations. And here again, we make an update and we set the travel status for this given keys. Yeah. What I now skipped is the determinations for the bookings. I need to quickly add them as well to the booking node, because there's also for this price update, there is two determinations, but as said, we cannot go into them or look into them into detail. The other one is for the booking ID that you will see that this one is also calculated for you. So I need to scroll down now to the booking implementation. And that is here. So this one I copy as well. So this goes into the other class, the behavior implementation class for the booking entity. By the way, you can expand this here nicely so that you can find the implementation classes that are associated. The implementation always takes place on the local types tab. I will insert my coding here, will do search and replace, and then it should work. We can now activate these two classes if there is no problem left. And then with that, the application, if these changes are reflected already, let me do a little refresh to give the system some time. So now when I do create and my coding is already considered, and everything is synchronized here, then you see that now the overall status is already set to O. Yeah, this is this on modify determination that is taking place on the triggering event create. And when I create a booking, that is the other determination that is taking place, that the booking number is already calculated when the draft record is created. Yeah, so as you can see here, we are still working in draft mode. So I can enter something here as a description. You see draft is saved, but so far no travel ID has been calculated. This will be done because it is specified in the behavior definition accordingly that the calculation of the travel ID only happens on save. Yeah. So just to demonstrate this was defined in this way. This means when we now activate, we are done with all these changes. And when I now activate and I am lucky and my changes are considered, it seems that this is not taking place. Okay, demo effect. Then the travel ID should have been calculated. So this is, I assume that now I'm hitting again the other app server where this is not present. So let me quickly delete this record and create it again so that you see that the travel ID, again, the overall status is defaulted. I click on save and now things are working. The travel ID 201 has been calculated, and this is simply happening inside this determination. We can very quickly take a look. It reads the travel IDs of the provided keys to make sure that we're not doing this multiple times. So we only make sure that those that do not have a travel ID are considered. And then typically we would ask a number range. In this case, we make our lives a little easier. We just do a select max from the table and add correspondingly one or as many records as we have received to the number. And by that, calculate the new semantic alternative keys here. Okay, then next thing is validations, right? Let me quickly scroll down. Correct, yeah. Validations. Validations require a little more overhead, and I think then I will also close. Maybe let's see how far we are in terms of time, because then we also have a little time left for questions and answers. Validations, as the name indicates, they are supposed to validate the data because, for instance, what you have seen is, although we have marked some of the attributes as mandatory, I have simply not touched them and left them empty, but saving was still possible. Yeah. And this is, of course, something you do not want in your application. So validations are very important. Validations typically, when things are violated or rules are violated, throw messages. So therefore, first thing you typically do is you need to specify corresponding T100 messages, and that we do as well. So we first create a message class in our package, and that we do via a right click again, message class here. And this message class, we give it a name. So, and store it. And we quickly need these few messages here. We'll quickly do that. I've prepared a few of them just to indicate a few messages that can be thrown. So I have these 5 messages here. 1, 2, 3, 4, 5. Oops, 5. So we'll quickly copy over these texts. You see they contain the regular placeholders where then variables can be inserted. That should be no magic to you. That is no new pattern. And already looking at the messages, you can most probably guess when and under which circumstances they are used. So we save this. Let's see, that was working. Okay. So we have now these 5 messages. And we also generate an exception class or make use of an exception class so that we use this exception class when the messages are supposed to be thrown. I will again make use here of some values that are prepared already. So again, similar as, okay, I'm now missed to specify here the interface, but this does not matter. We can, anyway, we will copy over again the prepared exception class that we have foreseen here. It defines it inherits from the statics check. It defines a number of interfaces and then the corresponding message constants that then can be used when we throw the corresponding messages. So the default pattern I apply here, I replace the defaulted coding and then I replace these placeholders with my initials to make my stuff unique. Here it is really important that you make sure that it's uppercase what you replace, because otherwise these strings might carry a lowercase value, and that is a kind of an issue then, because then the message IDs are not found. So yeah, so these constants, they specify a set of messages that then can be thrown inside the coding. So this is the recommended approach when you make use of messages that such class messages are used. Okay, but now to the actual validation. So this was a little preparation step. Now we want to add a few validations here. We want to have a validation for the agency, for the customer, and for the dates that were added. Again, we specify all this in the behavior definition. We add this right underneath our determinations. By the way, it does not matter where you put it. It is just to have some order. You could also move it further up here. Similar as before, each validation requires an implementation, and you can let the tool at least generate the method declaration as well as the empty implementations for you. But as in our cooking show, we have prepared obviously things. And again, we make use of this behavior implementation that gives us the implementation, including the validation code now. So I'll copy that over, replace the stuff with my placeholder, and then it should be fine. No, it isn't, because I again missed to activate my behavior definition. This I somehow need to learn. So I need to activate this first, because otherwise the declaration up there does not know what this is about, and therefore you cannot declare a validation for a behavior definition which does not yet have this in an active manner. Okay, so but how is this validation, for instance, working? Let's take a look at the agency validation very quickly again. So you see, again, we make use of the EML. So this is really a must-know topic, entity manipulation language. Without this, you won't have much fun with RAP. So in terms of efficiency, it's also really beneficial to learn and understand the entity manipulation language, because this is the only option for you to interact with the transactional buffer of the managed environment, but also the recommended way, of course, with an unmanaged scenario. So we read again the entities. No, we read from this entity all the agency IDs that are occurring. And let me quickly check. Am I still in the meeting? Yes, I am. Right. Okay, because I didn't see that. So we read the agency that are occurring, and we more or less make them distinct, so that we only check on the actual occurring agencies, so that if there's duplicates, we don't worry. And then we do a select on the database, because agencies are not yet reflected as a business object, so we cannot make use of a kind of a read by association or talk to a business object in the same manner, so that we would now do a read entities of the agency. So therefore, we need to make a select statement to check for the database. And check for missing ones. That means where, in which cases, an invalid agency has been entered. And that is done or checked then in this loop. So we loop over the occurring travels and the respective agencies inside. And if either the agency ID is initial or it does not exist on the database, then we throw an error. That we do in the sense that we first of all fill the failed keys. Failed keys means we communicate to the framework that this instance is in an inappropriate state and may not be saved. Yeah, so it is not correct, whatever the reason is, but it is not correct, and therefore we report this back by specifying a failed key, or this travel ID is reported as a failed one. And optionally, we can also specify messages. And this is what we obviously want to do, because we want to have a nice user experience, and we want to inform the user about what has been missed out here. And this we do by filling the corresponding entry into the reported structure. Yeah? So we always have, or in most of the cases, we have this pattern where you find in the signature failed and reported. And by failed or with failed, we communicate things that have not worked, or in this particular case are the instances that are in an erroneous situation. And optionally in the reported structure, you can specify why this is the case. It is not linked on purpose because you could have maybe no reported information, no T100 message for a failed key, or you could have multiple ones. Yeah, so it is not in a one-to-one relationship, and therefore it has been specified in two different data types here. Okay. This state area, that is something which is special to the handling of draft instances. This is used for so-called state messages. That means these messages are stored together with the draft state, because draft basically is nothing else than the so-called persistent buffer. Yeah, so like in a regular dialog transaction that you might know from the GUI, where you start a transaction, maybe MM02, yeah, a material master change, where you then work in the transaction, and while you do so, you obviously work on the buffer. And once you press F11, yeah, the save button, then everything is validated and persisted to the database. And this is actually the pattern of the draft. The draft is meant to enable this pattern in a stateless protocols. Yeah, so that we, for instance, in a Fiori Elements application, which makes use of HTTP and a stateless protocol in a stateless fashion, to also have the same kind of user experience, that you can work on a record as long, more or less, as you want, and only once you're done, you press OK, you press save, and then things are persisted. And this is the same thing here. So these state messages, they belong to the current state, which is persisted, and they are visible and stored as long as the draft instance exists. And when the draft is activated or deleted, then these state messages are also deleted. And yeah, these state messages allow you to specify these messages in the UI. Okay, in order to make use of these validations, we, as the last thing before we can run them, need to assign them to a so-called prepare action. That is a draft-specific action that is needed so that we explicitly list all the validations that we want to execute when the so-called prepare happens. The prepare call is an action that is triggered by the Fiori Elements UI when you click on save. Yeah, so this is technically split into two actions. There is this prepare action and the actual activation action. And there's on purpose split into two change sets of this single batch call, because in this batch call or in a dedicated change set, you might know that the pattern all or nothing applies. And the prepare message, the prepare determine action is needed in order to calculate the messages. And even if the instance cannot be activated because of errors, you still want to see the messages. And therefore, this is split into two actions. So there's always a prepare. And after the prepare, the actual activate is sent by the UI. And you need to assign validations. In this case, you could also assign determinations that you want explicitly to be executed when this prepare is taking place. So I have done this. I have now also activated. I didn't forget this time. And if I now, let's do a refresh just to be on the safe side. If I now try to save a record which breaks some of these validations, it should not be possible. By the way, in this version of the cloud environment, we unfortunately still have a little bug in there, because you will see that, and this is also highlighted here in the script, that there is an unnecessary pop-up that will come. The colleagues told and promised me that this is solved in the next release, which is planned to be available in more or less 4 weeks, 1 month, roughly. Then this should be gone. So if I leave everything empty here, so I'm breaking most of the validations, then first of all, okay, this was again the demo effect. So let's try it again. It does not want to do that. Okay, let's take a new one. Maybe that one is already worn out. Okay, we create a new one, and then we try to press save, and yeah, now I'm getting the messages. So this unspecified error, I said, you can please ignore. So this is how it should look like. It now complains about all these missing or inappropriate values. Yeah. So these 3 validations, they take care about the agency ID, the customer, and the begin start and end date so that they are validated accordingly, and that messages are thrown if any of these rules are not fulfilled. Okay, and looking at the time, I think we should definitely now look at questions and discussions, because I think the last exercise is basically about authorizations. We also marked it as optional because you can imagine, although it's a lot of prepared stuff and a lot of copy and paste actions, it's still, yeah, the entire exercise is, or the entire session is quite comprehensive, and yeah, it's hard to achieve that in that given time window. So therefore, yeah, also now with all my explanations, it took quite a while. So therefore, I think we can then, should we move then? Let me maybe stop sharing then, and you share. Now I can, there's the stop share. I just need to read, and then maybe asking my colleagues. I hope you have been busy in answering most of the questions already in the meantime. Karin, Stefan, Simon. Still somebody there?
Yeah, we are there. We are still there, Volker.
Good.
We were busy in the Q&A, answering questions. So I don't know if there is the possibility to talk over the phone, but from the Q&A side, I mean, we are pretty good right now.
Oh yeah, I see 30 answered. Wow, thanks for taking care of them.
Yeah, so I don't know if not, then maybe we can go ahead. If somebody wants to ask a question via phone, please just raise your hand or take over. If not, I will just, we have some 2-3 slides to show you again before the end of the session. So first, quotes as a summary, we just want to show you the major deliveries we made for the cloud and the on-premise shipments in the year 2020. Regarding Managed BO, for example, RAP is supported on SAP S4 HANA starting with 1909 release, so in 2019, but we only support the brownfield, so the unmanaged scenario. So the managed scenario that has been shown for the in the demo, thank you for that, Volker, is now also available on premise with the 2020 release. And there also we have different aspects like the external and UUI-based numbering, and so a lot of enhancement there for the cloud and a lot of new stuff for the on-premise world. The draft handling is also now supported in both deployment environments, so cloud and on-premise. And this is, as you have seen in the demo, it is very important. For example, when you build application, like I mentioned in the intro, we are working with stateless technologies, but of course, many applications have kind of stateful, are of stateful nature. So, and the draft is there to fill the gap between the application requirements and the UI and the technologies we are using. Also, we have major improvement, enhancement common to both words, the managed BO and the unmanaged BOs. And an additional point here is that we support the Auditor v4 protocol in the cloud already since the November release. And this year we will soon also support the Auditor v4 protocol on premise. And very soon. It's a plan with one of the feature pack of the 2020. So customer in 2020 will not have to wait till the new release. Also regarding the testability, we also now offer double frameworks for business objects and also documentability. We have a new artifact in ABAP, how you can provide your own documentation for a range of ABAP objects, the so-called knowledge transfer documents. So they are available for CDS artifact, for the CDS service binding, but also for classes and other artifacts. It's really powerful, and you can find also various video we have rolled out for that in the community or on our ABAP channel, ABAP YouTube channel. So key takeaways: RAP helps you to rapidly develop enterprise-grade OData services, which are interestingly built in for the cloud and best support SAP HANA and also SAP Fiori, in particular SAP Fiori elements. That's what you have shown. You have seen in the demo how we can also enrich a OData service to have a Fiori element app rendered. And we did it with the CDS Metadata Extension on the ABAP platform, but typically it is done in the web, in the SAP Fiori tools, where you can use templates to create your applications. RAP is available in the ABAP environment in the cloud, our so-called SAP Business Technology platform, so the SAP Cloud platform, as well on, available on premise as well with SAP S/4HANA 1909 and higher releases. We enhance the RAP feature scope on a quarterly basis in the cloud and on a yearly basis on SAP in SAP S/4HANA. Yeah, you can also have information on the next planned innovation by just visiting the SAP Roadmap Explorer. We offered a free open SAP course last year from October to December. Was the live period, but now the course is still available as self-paced mode, and there we cover all the different aspects of the RAP, also the unmanaged scenario and aspect also like service consumption model. So we encourage you to go register enroll to the course for the course, and then you can go at your own space through the different exercises. There are various videos offered, but also step-by-step hands-on exercises like the one you just saw now. We have various information that are in the appendix of this presentation. So when you get the presentation afterward, I don't know if that will be the case, you can go through the links. The presentation is also available on the GitHub repository, at least those links. Having said that, thank you very much for our site again. I'm handing over to you, Ian.
Thank you very much. Thank you, Corinne. Thank you, Stefan, Volker, Simon. Thank you for answering all the questions. And just to remind everybody, this recording will be available probably within the next 48 hours on the SAP Community YouTube channel. I will stop recording soon. Thank you for all attending. And if you have any more questions, we'll leave the webinar available just for a few more minutes. If your questions have not been answered, please visit community.sap.com, where you can ask your questions, and we wish you a very great day. Thank you very much.